Good morning, student. Welcome back once again. I will begin with the same chapter, that is electric current. I hope that all of you are doing well and doing practice of maths and science and other subjects. Children, last time I have completed till the page number 34, that is Ohm's law and the resistance and resistivity of conductor. Now, I will continue the same chapter with the next topic, that is electric circuit. Today I will cover few parts of this chapter, and I will try to complete this chapter. And that few topics are electric circuit, then about the materials like conductors and insulator, then how we are going to connect the resistance, the systems, that is series and parallel. Okay, so just see your textbook. Very important part is what always you should keep your textbook and just see how I am explaining that one, because it required diagram. This chapter mainly required diagram, and it is very useful, children, after 10th standard when you will take science. So you are going to get this electric circuit part. So as you can see here, I have drawn a electrical circuit diagram. In this electrical circuit diagram, you will see there are various components. So we have to see the use of these components. Means what is the use of ammeter, what is the use of voltmeter, then what is resistance, then what is battery electrical cell, which is called as an electrical cell. Now first of all, this diagram, I said it is a circuit diagram. Okay, why? The reason for this, the flow of current is continuous. The flow of current is continuous between the two ends of the terminal, between the two ends of the battery. These two ends are this and this. The flow of current is continuous between the two ends, right? Just see here, the bigger line indicates the positive terminal and the smaller one indicates the negative terminal. From here what will happen? Electron will flow, and I said in my previous videos that if electron is flowing in this direction, children, so what will happen? Current will flow in these directions. So here this is a continuous flow of current from one terminal or one end of the electric cell to the another end of the electric cell. So this is called as a circuit diagram. Now see in textbook what is given: a continuous path of an electric current. A continuous path of an electric current. Current is flowing in this direction and it is continuous without stopping. It is continuous between through the conducting wires. This is a conducting wire. This black one is a conducting wire. Conducting wire means what, children? It is a copper wire, aluminium wire, you can say, right? So all these are the conducting. This is the conducting wire, and current is flowing continuously through this conducting wire from one end of the cell to the other end of the cell. So this is called as a circuit diagram. And now what are the uses of this component here? This ammeter, it measures the amount of current. In the laboratory you will see this apparatus, right? When school will start, I will take you in the laboratory in physics lab. There I will show you what is this. It is an apparatus which measures the current, and the unit of current is ampere. So I have written here A. Next is, this is what? This is the voltmeter, which measures the potential difference, and it is denoted by V. What about this? This is the resistance, right? And it is denoted by R. Its unit is ohm. This black line is a conducting wire, that is copper I said, aluminium I said, and it has two terminals. The bigger line indicates the positive terminal and the smaller one indicates the negative terminal. So here this figure shows how different components are to be connected in the circuit by using the special symbols. Means for ammeter it is A, for voltmeter it is V, for resistance it is R, and here it is the conducting wire. So children, ammeter is useful to measure the current and voltmeter is useful to measure the potential difference between the two ends of a resistor. So children, this is about electric circuit. The next part of this is conductors. I said about the conductors and insulators. Okay. The next part is conductor and insulators. So children, now we will see the conductors and insulator. If you see your textbook on page number 36, they have given a topic that try this. Actually, this part is omitted. This part is omitted for this year, but it is based, the conductors and insulator based on this. They have given some materials like copper, aluminium wire, aluminium wire, glass rod, and rubber. We have to find out of all this which is a good conductor and which is a bad conductor, means insulator. So first, to find out that part, you should know what is the meaning of conductor and what is the meaning of insulators, means bad conductors. So children, see here I have written what is the meaning of good conductors. Those substances which have very low resistance. I told you in resistivity part that every substance have some hindrance, means along with the free charges there are some atoms, there are some ions which stops the flow of current, which stops the flow of electrons, right? So the substance which have less this hindrance, means they have very low resistance, they are called as good conductors. Example, we are using copper wire in a house. Okay, so this copper wire has less hindrance, means less ions, less atoms. They easily allow the flow of electrons. That is why these are called as a good conductors. These substances are called as a good conductors. So those substances which have very low resistance, right, means they allow the flow of electron easily, are called as a good conductors. You can say the examples are silver, then copper, aluminium. All these are good examples of conductors. Okay children. On other hand, if you see here, insulators means bad conductors. So those substances which have extremely high resistance, means which substance stops the flow of electrons. The hindrance means the things which are present inside that substance stops the electrons. That is they are called as insulators, which have high resistance and do not allow the flow of electrons. If the substance do not allow the flow of electron, means what will happen? The current will not flow, right? So that substance are called as insulators. You can say rubber, you can say wood, glass. All these are the bad conductors, children. So I hope that all of you have understood the topic which is given on page number 37. Children, there are two questions. I want to give the answer of these two questions. Number one is given here, why are some substance conductors while others are insulators? Very simple answer. The substance which have free positive and negative charges. The substance which have free positive, this substance have free positive and negative charges, so they are good conductors, and the substance which do not have free positive and negative charges are the bad conductors. That is why some substances are good conductors and some are bad conductors, means insulators. Now second question is given here, why can our body conduct electricity? Answer is yes. Our body can conduct electricity, right? What is the reason behind that? The reason behind that, our body have free positive and negative charges. Our body have free positive and negative charges. That is why a body is a good conductor of electricity. So I hope that you have understood this topic about conductors and insulators. Next topic I will do here, how we are going to connect the resistance, right? What are that two systems, the resistance which are connected in a series and the resistance which are connected in a parallel. So now next topic is connection of resistance in series and parallel. So children, now see here how the resistors are connected with each other. So there are two systems. One is called as a series and second one is called as a parallel. Now we are going to see the connection of these resistors and what happened to the potential difference and the current. So first one is when the resistors is connected in series combinations. So just see your page number 39, what is given here. Always every resistors, see here I have drawn this one. This is the symbol of resistor. Every resistors have two ends. You can see here one and this. And that resistor have some amount. That resistor have some amount. I have given you example. Resistor is denoted by R and let the value of this resistor is 10 ohm. And this is connected with the cell, with the battery. Okay. In several electrical devices, means like I will say your TV, you can say fridge, oven, or in all these electrical devices, these resistors are connected, not a single, in number of means 2 resistors, 3 resistors, 4 resistors are connected in our home appliances, electrical appliances, and for all all these have different values. All resistors have different values. Ohm's law is applicable. Ohm's law you have done, children. Ohm's law means potential difference V is equal to R is applicable for such connections. So see what happens to the electric current and potential difference when the resistors is connected in a series. Here I have drawn a circuit diagram. You can see in this circuit diagram there are 3 resistors. I have given them as name R1, R2 and R3. And across this there is a potential difference. Like this I can connect the second one and the third one. So this will become V1, this will become V2 and V3. This is what ammeter, it measures the current, and this is key, right? And this is your battery. The current will flow like this in these directions. So this connection you understood, children? See once again, in this circuit diagram I have connected 3 resistors one after the another. It is in a single line. That is why this is called as a resistor in series. The resistors are connected one after another. Means one after another. The second end of this resistor is this and the first end of this resistor is, these two are connected like that here in a single line. That is why this combination is called as a resistor in series. Okay, so here you can see that the ends of the 3 resistors are connected so that they follow one after the other in single line. The current follow one after the another in single line. This is the meaning of resistor in series. These resistors are said to be connected in series. That already I have told you, children, that the resistors are connected one after another, right? एक के बाद दूसरा, like that, one after another. Okay, and it is in a single line. That is why this combination of resistor is called as a resistor in series. And what is the very important part in this, children? The very important part in this is each resistor have same amount of current. That is the very important part. Whenever you are going to write answer of this question, so this line you should mark it, that in series combination each resistor is having same amount of current. So you can see these resistors are said to be connected in series. In such an arrangement, the same current flows through each resistor. Keep in mind, in all the resistors, same amount of current is flowing. This very important line. The value of current is I. The current which is flowing through these three resistors, just take it as I. Whatever is current flowing here, same amount of here, same amount of here. So current is same in all the cases. The value of current is I and the potential difference between C and D is V. The potential difference between point C and D is denoted by V and the current is denoted by I. The three resistors R1, R2 and R3 are connected in series in the circuit. Let the voltage, already I told you children, if I will take here V, so the potential difference across this point and this point is this one. So I will take this one as V1. Similarly, from this point to this point, if I will connect another potential difference, another voltmeter, so it is V2 and like that this is V3. So there are three potential difference V1, V2 and V3. So V1, V2, V3 respectively. Now already I told that the total potential difference between the terminal C and D is what? V, and that we are divided into V1, V2 and V3. Simple. The potential difference between C and D, C और D के बीच का potential difference, how you will find out? It is the sum of across these three resistors. यहाँ पे how much it is? It is V1, this is V2, this is V3. So if you want to find out the potential difference between C and D, you will take V is equal to V1 plus V2 plus V3. So here first point you will write that V is equal to potential difference, V is equal to V1 plus V2 plus V3. Potential difference is different children, but current flowing through this resistor is same. And the total potential difference between point C and D is V. So that V, how you will get? V1 plus V2 plus V3, and this is your equation number 1. Just put that equation number 1. If RS, see the symbol is given RS. What is RS here? R means resistor and S means series. So RS indicates the effective resistance when it is connected in a series combination. So here RS, S for series, is the effective resistance between C and D. Then according to Ohm's law, if you want to find out the effective resistors between C and D, so that is represented by what? RS, effective resistance, RS. If you want to find out that one, so you should apply here Ohm's law. Now V is equal to, we know that V is equal to IR. But since we want to calculate here effective resistance, that is why we will write here V is equal to IRS. We will write here I is equal to RS. We have to calculate this RS. So that is why I have written Ohm's law, V equal to IR. Since you want to calculate this, so write down here IRS. And then afterwards, we have V1, V is equal to IR, Ohm's law. So what about V1? Current is same, so do not write here I1, write this one as it is. But there are three resistors, so write R1. What about V2? V2 is equal to IR2. V3, it is equal to IR3. Current is same children through these three resistors. This is Ohm's law. This is what? Ohm's law. Ohm's law. And now take, with the help of this, first you find out potential difference across this resistor. It is V1, so IR1. Across second resistor, so it is IR2. Across third resistors, IR3. After all this, put these values in equation number 1. See, V is equal to V1 plus V2 plus V3. Substitute this V1 here. So what about V equal to, children? This V1 will be I R1 plus V2 is here. It is I R2 and this is I R3. Got it? This IR1 here, IR2 and IR3. You have substituted this V1, V2, V3 in equation number 1. Also V is equal to what? V is equal to IRS. We will take this one because we want to calculate RS. So here write down IRS is equal to I. And among these three, what is common? Among these three, I is common. So remaining is R1 plus R2 plus R3. Divide both the side by I. If you will divide both the side by, what will happen? IRS upon I is equal to I bracket R1 plus R2 plus R3. Divide this by I. So this I and I get cancelled. I and I. Why you have divided by I here? Because you want to calculate RS. So you will get RS is equal to R1 plus R2 plus R3. Right, children? So here you got the result of effective resistance. Like this, if suppose there are 10 resistors are connected. So what you will get effective resistance here? R1 plus R2 plus R3 plus R4 plus R5 up to 10. So in the textbook it is given that if there are n resistors instead of 3 and 10, if there are n resistors, so what you will get for RS is equal to R1 plus R2 plus R3 plus right last one as Rn. So this is the effective resistors. Now children, I will give you one example how they will ask you question in exam or in textbook, how they have asked. Suppose the two resistors are connected in a series combination. Let R1 is 10 ohm and R2 is 20 ohm. R1 is 10 ohm and R2 is 20 ohm. And the question comes like this. What is the effective resistance when these two are connected in series? What is the effective resistance? So I have given you formula for effective resistance. Here I am having only two resistance. So what I will do, I will write RS is equal to, in this case, RS is equal to R1 plus R2, because I am having only two resistors. So R1 is 10 and R2 is 20, it is equal to 30 ohm. So effective resistance is equal to 30 ohm. So I hope that all of you have understood this part, that when the resistors are connected in series, so how to calculate the effective resistance. So I said that the current flowing through each resistor is same. Potential difference across each resistor is different. How to calculate potential difference here? Between the point C and D, it is the sum of these three potential difference, V1 plus V2 plus V3. Okay, and then just apply Ohm's law, get V1, get V2, V3, substitute these two values in this case and get these equations. Replace this V by IRS. Okay, take down I common, divide throughout by I, you will get your answers. So RS is equal to R1 plus R2 plus R3. This is about your register in series. Now children, backside they have given example also in the textbook. If you see page number 40, they have given examples, that is 3 resistors having resistance, 3 resistors. So how you will take R1 as 15 ohm, R2 as 3 ohm and R3 has 4 ohms. I already told you, if you are having the textbook, then it becomes very easy. So children, please, if you are not having, open your textbook and see your page number 40. I am giving examples of resistance in series, how the sums can ask in the textbook or in exam. So the resistors having resistance of 15 ohm, 3 ohm and 4 ohms are connected in series. So you will take R1, R2, R3. And the question is, what is the effective resistance in this circuit? So formula, Rs is equal to R1 plus R2 plus R3. Substitute all the values. 15 plus 3 plus 4 is equal to 22 ohm. Okay, like that second example is given in your textbook. Go through that one. So I hope that all of you have understood a very important topic of the chapter, that is resistor in series. Now I will do the next part of the chapter, that is resistor in parallel.